Welcome to The Explainer. I am incredibly excited to dive into this with you today. We're going to completely unpack the critical points of failure and success inside a Retrieval-Augmented Generation pipeline, or, as we all know it, RAG. Look, if you're building AI apps right now, you already know RAG is the absolute gold standard for hooking up a large language model to your private data. But as we're going to see, getting this right, it's a whole lot harder than just slapping an API onto a database. Okay, let's jump right in.
So here's a question that honestly haunts pretty much every AI developer I know. Have you ever asked your RAG system a question, gotten back this beautifully written, super confident answer, and then realized it was completely, undeniably false? Yeah, it's incredibly frustrating, right? You built this whole system specifically to rely on hard facts, but it still acts like it's just making things up on the fly. So why does that happen? Well, to figure that out, we really need to look at the actual mechanics of how these systems break down.
Section 1. The RAG hallucination trap. When bad retrieval corrupts good models.
Think of your large language model like a brilliant, highly articulate research assistant. But, even the smartest assistant on the planet is going to write a terrible report if you hand them the wrong books to read. The absolute most dangerous symptom of a failing RAG system is when it becomes what we call fluent but hallucinated. See, your generator model is insanely good at stringing words together. So when you feed it the wrong information, it doesn't just give you a simple error code. No, it lies to you, and it sounds perfectly natural doing it.
And this sets off a really nasty domino effect. It all kicks off with a weak retriever fetching irrelevant or just noisy document chunks. Now, because the generator relies entirely on this retrieve context, that noisy data completely degrades the prompt. And the final domino to fall? The generator spits out those fluent, totally hallucinated answers based purely on the garbage it was handed. It's the ultimate case of garbage in, garbage out.
Section 2. Diagnosing the failures. Let's look at exactly why retrievers fall short.
Whenever a retriever is pulling in bad data, there's a specific 4-step checklist of culprits we need to investigate. We're looking at the state of your knowledge base, your actual retrieval model, the quality of your embeddings, and finally, the level of domain-specific fine-tuning. Let's pop the hood and unpack what's going wrong with each of these.
All right, culprit number 1 is the most fundamental, an outdated or incomplete knowledge base. Basically, if your foundational data is old or if it's just missing entirely, the retriever literally cannot access the right information. It's a hard limit on accuracy. Even if you have the most advanced, state-of-the-art model in the world, it's going to fail if the answer simply isn't in the database to begin with.
Culprit number 2. Using a weak retrieval model. You've got older models out there like TF-IDF or BM25, and they're essentially just keyword matchers. They literally look for exact word overlaps. Now, compare that to modern, dense vector models, which actually understand the underlying semantic meaning behind the text. If you're still sticking with those older keyword models, you are practically guaranteeing less effective retrieval.
Moving on to the third issue, low-quality embeddings. You can think of embeddings as the critical translator between human language and machine logic. If you're relying on low-quality embeddings, you massively reduce the semantic understanding between what the user is asking and what the document chunks actually mean. It's exactly like having a terrible translator in the room. The user asks a question, the embeddings completely mistranslate the intent, and boom, the system pulls up a bunch of totally mismatched documents.
And the final trap here is a lack of domain-specific fine-tuning. Out of the box, standard embedding models are fantastic for general knowledge, sure. But they often completely fail to capture the subtle nuances or the dense jargon of highly specialized fields. Think legal contracts or complex medical journals. Missing that specific niche vocabulary is a huge blind spot that leads to severe retrieval errors.
Section 3. Mastering document chunking, the foundational fix.
Okay, so we've diagnosed the retriever itself, but what if the root of the problem actually starts before the data is ever even searched? If there is one single rule you need to remember from this entire explainer, it's this. One size absolutely does not fit all. If you're just slicing all your text into equal 500-word blocks, completely ignoring the document's actual contents, you are destroying the semantic meaning of your data before the AI even gets a chance to see it. It is a fatal error.
To fix this, we have to divide your data universe into 2 completely distinct categories. First up, structured documents. These are your complex PDFs, files loaded with tables, figures, headers, and distinct page layouts.
Then, on the other side, you have plain text documents. As you can probably guess, those highly complex layouts require a totally different, much more careful chunking strategy than simple text.
So let's map out the right strategy for each document type. For those tricky structured documents, agentic and recursive chunking are your best friends because they actively respect that complex layout and context. Meanwhile, for your plain text documents, fixed size and semantic chunking are totally ideal because they prioritize semantic coherence and keep things simple.
Because structured documents are so incredibly tricky, your chunking strategy has to rigorously respect the document elements. You have to preserve your tables and figures as whole units. You need to maintain the relationship between headers and their corresponding pages. If you just blindly chop a data table right down the middle, you completely destroy its semantic meaning, and you're going to leave your RAG system completely confused. Protecting that layout context is absolutely paramount.
Section 4, Building Stronger AI Systems. Let's look at the core takeaway. We've covered a lot of ground today, from diagnosing those frustrating hallucinated symptoms all the way to implementing structural chunking cures. But it really all boils down to this. Strong retrievers are necessary to provide the most relevant context and ensure factual and relevant outputs in RAG systems. Seriously, the retriever is the true gatekeeper of quality here. If you fix your document chunking, upgrade to dense vector models, use high-quality embeddings, and keep your data fresh, that is exactly how you transform a weak link into an incredibly strong retriever.
I really want to leave you with this final, provocative thought. Ask yourself right now, is your knowledge base up to date, or is your LLM just guessing with absolute confidence? Don't wait on this. Go audit your own RAG pipelines today. Check those chunking strategies, investigate your embeddings, and make absolutely sure your retriever isn't the hidden reason your model is hallucinating. Thank you so much for joining me for this explainer. Keep learning and keep building.